Welcome to level 3 of 100 paradoxes. This one comes from ancient Greece and challenges our understanding of motion and time. It's called Zeno's Achilles and the tortoise paradox. Imagine a race between Achilles, the great Greek warrior, and a slow-moving tortoise. To make things fair, the tortoise gets a head start, let's say 10 meters ahead. Achilles is much faster, so you would think he should easily overtake the tortoise. But Zeno argued that Achilles can never actually catch up. Here's the reasoning. First, Achilles reaches the point where the tortoise started, but in that time, the tortoise has moved forward a little bit. Next, Achilles reaches that new position, but again, the tortoise has moved slightly ahead. This keeps happening indefinitely. Every time Achilles gets to where the tortoise was, the tortoise has inched forward. Even though the distances get smaller and smaller, there are infinitely many steps Achilles must take. So, according to Zeno, Achilles is stuck in an infinite sequence and can never actually reach the tortoise. Of course, in reality, we know that Achilles will easily overtake the tortoise. So, what's wrong with Zeno's reasoning? The paradox comes from the idea that dividing distance into infinite smaller parts means infinite time is needed to complete them. But, in reality, an infinite series can have a finite sum. The time Achilles takes in each step gets shorter and shorter, and all the steps together add up to a finite amount of time. This paradox puzzled philosophers and mathematicians for centuries until the development of calculus. Mathematicians like Newton and Leibniz showed that infinite sequences can converge to a finite number, resolving the paradox. But Zeno's paradox still raises deep questions about the nature of time, space, and motion. Is motion continuous, or does it happen in discrete jumps? If space is infinitely divisible, does that mean reality itself is made of infinite steps?